Welcome back to the C programming language in action. In this module, I want to show you how to move from C to C++. Having started with C, C++ is your natural next step as you move up the productivity ladder and consider what C++ has to offer. C++ is a no-compromise next step for the C programmer. It doesn't force you into using any runtime features or add any overhead that might cause you to turn back to C. It has some optional features that do impose some overhead, but you're free to ignore them. Especially in the area of embedded systems programming, C can help tremendously in simplifying the complex resource management tasks. Let's take a look at some differences between C and C++ in this module, and how you might make use of C++ to simplify your applications. I'd say the most obvious difference between C and C++ is that C++ offers member functions. Sure, C has structures, but in C++ you can write functions that are members of those structures. This has some minor syntactic benefits. Let's say we have a database connection that we need to represent. In C, we'd perhaps start with something like this. We then need to add some functions to negotiate with a connection. Perhaps a function to open a database connection. And a function to execute a SQL statement. And, at the very least, a function to close the connection. Now, given that we've wrapped the connection structure in a typedef, we can define a connection in our main function. We can open this connection. We can execute a SQL statement. And finally, we can close the connection. Now, as we move to C++, there are a number of things that we can do to improve this code. But in this segment, let's just focus on the ability to define member functions. We can take all three of these functions and make them members of the connection structure. But before I do that, let's remove this ugly typedef, as C++ has no need of it. Okay, now we can simply move the functions into the structure. Now, as member functions, there are some benefits that these functions provide. First and foremost, they carry an implicit parameter, which links the function calls with the object that they are called on. To understand what this means, we first need to look at how these member functions would be called. So here we're telling the compiler that we have an object, this variable called db, and we want to call these member functions, often called methods, on this object. What the compiler then does is pass the address of this object to each and every member function automatically or implicitly. That means that these methods need not include this explicit connection parameter. Instead, there's an implicit this parameter that we can refer to. This refers to this object that the current method call is dependent on. But this pointer, called this, is also optional in most cases, and you can simply refer to the member variables directly. Now, given that these are member functions or methods, they are scoped to the structure in which they've been declared. We don't need their names to be decorated with the word connection, since it's unambiguous. There are no other functions that will conflict with these names since they're in their own namespace, the namespace of the connection structure. Now, our program's main function is also greatly simplified. It's easier to read and simpler to write with member functions. But it's not any more reliable. C++ introduces a special set of member functions just for that, and that's up next. While normal member functions are a convenience, the special member functions, namely constructors and destructors, are indispensable to the C++ programmer. Not so much because C++ needs it, but because C really lacks without it. You can use C++ without constructors and destructors, just like you can use it in C, but they really change the game when writing applications in C++. This main function is very simple, but a lot of code is rarely this straightforward. It's not nearly as obvious in practice if you forget to close the connection or improperly initialize the object in the first place. C++ defines a whole set of special member functions, two of which I want to point out here. Rather than having to remember to call the close method at the end of the scope, we can add a destructor that the compiler will ensure is called before the variable, the database connection, goes out of scope. Before this main function returns, in other words. The destructor carries the same name as the structure with a squiggly before it. Now, given this destructor, we don't need to call the close method explicitly. We could, of course, move the functionality of the close method directly into the destructor, but then we couldn't close the connection directly if we so chose. That's more of a design decision. This use of a destructor might seem like a minor convenience, but it's actually quite complete. If we, for example, later on decided to return from this function early, like this, for whatever reason, the connection would still be closed as the compiler would ensure the destructor is called no matter how execution leaves the scope. I haven't even talked about exceptions, but if you've heard of those, even in the face of exceptions, the connection destructor would still get executed. So that's destruction, but what about construction? Well, you can also define a special member function called a constructor to initialize an object. Here we ensure that the object is initialized to some well-known state before the caller is able to use it. Again, the constructor uses the name of the structure. We could even have the constructor accept a parameter and open the connection right from the start. But that's not essential, and it's often useful to have a connection object without immediately having to open it. Again, that's more of a design decision that you can make up for yourself. To make this clear, let's just print a message inside the constructor and destructor, and you'll see how both of these special member functions are called automatically, despite no visible sign of them in the main function. That's the constructor. And the destructor. Okay, let's take a look. Notice again that before we go that the main function is much as before, but in fact has less going on. There's no explicit close, no explicit call to a destructor, and no explicit call to a constructor, and yet it's all taken care of for us. We can just ignore the warnings for the unused parameters. And there you can clearly see that the constructor and destructor are called thanks to the C++ language and compiler. Now C++ offers a twist on structures, and they're called classes. In C++, a class and structure are very similar. In fact, their only differences are in the default accessibility they offer to members and inheritance. Which brings us to the issue of privacy or accessibility. In C++, you can declare different members of a structure or class as either public, protected, or private. In this example, we may want to hide the implementation from the caller so that the caller does not accidentally change the internal state of the connection. For structures, the accessibility of members is public by default, but we can override that for parts of the class or structure. Now, everything following the private label will not be accessible outside of the structure up until the public label. Everything following that label will again be accessible. The only difference between classes and structures is in these defaults. We can change this to a class, and everything will continue to work just fine. But now we can also optionally remove the leading private label, since private is assumed for classes. And that's all there is to it. C++ has a much stronger notion of const than C. Const can and often does define constant expressions. You can declare local variables const so that they may not change once initialized, and declare member functions, methods, const, so that they may not change the state of the object they represent. In this example, there are a few places where we can and should strengthen the constness of our connection class. For starters, anywhere a parameter does not need to be changed, which is most of the time, it should be const. If the connection state does not need to change during execution, we might even mark the execute method as const. Now, this has a few useful effects on the application. Firstly, we are assuming to a strong degree that the execute method is not making changes to the internal state of the connection. This is just one less thing to worry about as we maintain our code. But we can now also use the execute method in places where we only have a const connection. Imagine we have a non-member function where we prepare the database. There are a couple things worth mentioning here. First, this function will only be using const methods on the connection, so the connection itself should be const. This again assures us that this function is not changing the state of the connection, making it easier to reason about our program. Second, this parameter is a reference, not a pointer or a value. References are also new to C++. They're much like pointers in that they don't copy the value or variable, but they do provide the syntactic convenience of values. They also provide some assurance that you're pointing to an actual object, not a null pointer. We can now call the connection's execute method by virtue of its being const and use a simpler syntax to call it. And that's a little about const correctness in C++. We've only scratched the surface of what C++ offers, but there is clearly many good reasons to consider C++ as your next step now that you're familiar with the C programming language, a language that, despite and perhaps because of its simplicity, continues to play such a foundational role not only in C++ applications, but also in many environments where only C, or at least the C subset of C++, can be tolerated. As you begin to explore C++, you'll appreciate the ability to create member functions, functions often called methods that are associated with an object implicitly. While member functions in general provide some degree of convenience and elegance, constructors and destructors play a critical and foundational role in turning C++ into an elegant language in which to build large-scale applications that necessarily manage large numbers of resources efficiently and correctly. C++ also augments the notion of a struct with the ability to define the accessibility of its members and introduces classes, a variant of structs, with private accessibility by default. Const is a major part of the C++ language, a major improvement in the ability to reason about the correctness of programs, and a simple way to avoid many subtle bugs by ensuring the values cannot change accidentally. And of course, references enable value semantics and avoid many cases where pointers would have to be used in C with no loss in performance. One of the interesting things I didn't illustrate was the notion of function overloading. Libraries of C functions often have their names decorated to distinguish perhaps between functions that accept one type of variable or another, or different combinations of values. In C++, you can overload functions, giving different functions the same name, and the compiler will resolve which overload to call based on the arguments provided. This is great for library development. And of course, inline functions. Although these have been added recently to the C standard, it's not very widely available. But inline functions are a welcome addition as they allow us to avoid many cases where we used macros in C. And then there are templates. Templates are such a wonderful feature of the C++ language. You will see me use templates in practically all of my other courses here on Pluralsight. They enable a world of generic programming that would otherwise be impossible. And that brings us to the end of the C programming language in action. I hope you've enjoyed the course. From here on, your options are wide open. You have a solid foundation in the most influential programming language in history. You can take your newly acquired skills and go on to program practically any computer on the planet. You can take it further with my courses on C++ and Windows programming, and